All right, so last time we left off with the board, we had put the FPGA on the board. Now what I'm going to do is follow my instructions with the bill of materials and the schematic. And with these materials and the assembly instructions, you should be able to kind of follow along and assemble this OwlFPGA board. So first thing is we need to make sure that you wear safety glasses throughout the whole process. The soldering iron gets really hot, so be careful. I don't want to get burned. You don't want to get burned, but especially I really just don't want to get burned. So some tools that we're going to need are the wire clippers. We're going to need desoldering braid, and I'll show you how to use that hopefully. We'll need some solder, and we'll need a pair of tweezers. The first thing that it says here, let's see here, U4, C2, and C9. So if you look at the bill of materials, you'll find that U4 is a 1.8 volt regulator. 1.8 volt regulator goes right here. And I'm going to flip the board around because it's easier to solder that way. So I have the 1.8 regulator. Essentially what we're going to do for the regulator, I'm going to heat up this pad over here. Ooh, I'm going to clean the tip, a little dirty. Apply heat to the pad. Oh, I think the soldering iron needs to be set. The temperature's wrong. As you go along, you're going to have a soldering station. If you need to clean the tip, you can use a sponge after wetting it with water. So I'll put some water in it. This is my drinking water, but whatever. No drinking or eating in the lab while you're soldering. So you can use a sponge to clean off the tip, or you can use this over here. But seriously, you really don't want to eat or drink. You want to wash your hands after you do this because this, depending on what year you're doing this in, it may be lead-free or leaded solder, but we'll also have flux here, and we'll be using flux, so you really do need to wash your hands afterwards. Anyway, I think the station's heated up now, so I will heat up this pad and then feed in some solder into the pad. I'm going to use the tweezers and then push the part in until the joint looks nice and shiny and the part is correctly aligned. And there we go. Release the iron, then keep the part there for a little bit longer. And when you're soldering components with two sides, you want to make sure you leave enough room on the other side to actually apply solder. So what I'm going to do is go back on the other side now, and I'm going to go ahead and fill solder in on these other pins, remembering that less is more. You want to touch both the pad and the pin. Okay, so what I'm going to do on purpose is I'm going to bridge something on purpose here. Oh no, we applied too much solder, right? So all we need to do is, sometimes you can just apply a little bit of heat and it'll kind of get the solder flowing out. Other times you'll need to apply some braid. Apply the braid to the pins and the pads. Try not to do that. And then we're just going to let it heat up. And the braid should wick away the solder. Don't apply too much pressure on the part, you might break it. Or you might bend the leads, especially on the parts that are finer pitch. There's a pretty wide pitch here, so you probably won't break it, but if it's a finer pitch part, you're going to have issues with that. So now it's a C2 and C9. So C2 and C9, according to my bill of materials, is going to be 0805 10 microfarad capacitor. So here. Those are 10 microfarad capacitors. C2 and C4, C2 and C9 are over here. And the order of assembly I'm doing this time is the parts needed to minimally test the board to make sure that the BGA is mounted properly. So when you have a 2-pin package, what we're going to do is just apply solder to one side, pick the part up with the tweezers, and apply heat. Let go of the iron, and then hold on to the part for a couple seconds just to make sure it stays there. Next part is going to be C2, which is a 10 microfarad capacitor. Apply heat with the solder, pick the part up. Oops. Okay, so sometimes the joint will flare up a little. So what we want to do is also just solder the other side, come back and solder the other side first. So remember, less solder is more. Don't apply too much solder. And then if we see the flared up joint, I hope you can see that on the camera. Probably not, but if the joint doesn't look smooth, we just apply a little flux, apply a little heat to it, and then it'll smooth out. So I'm not using the fume extractor or the fan to blow away smoke right now because as we're recording it's going to get really loud, but in lab you should be using the fume extractor of some sort to just blow the smoke away from you. I mean, it's not particularly hazardous, but you don't want to be breathing this in. It doesn't smell that good. So C2, C9, then the next one, and before I move on, there's going to be a part called U4 and U5. They look identical. If you put the part in back, you reverse the two parts. This one's a 1.8 volt regulator and this is a 3.3 volt regulator. If you reverse them, you will probably damage the FPGA, so be very careful between U4 and U5. So let's go ahead and pick up U5. Here's a U5. And I'm going to again apply solder to this pad over here. Pick the part up, align it in such a way that you can still solder the other side. A good joint is going to look shiny, and you want the part as flush as possible. Now, a caveat on that is when you're using lead solder, it's going to come out shiny, but lead-free solder tends to leave a duller joint, so you should expect that if that's the case. And we're going to come on the other side, apply solder on each pin, noting that both the pin and the pad should be coated, so it should look shiny. Oops, what I just, I put some solder on there. I'll hopefully, we'll fix that later. So the U5 is in, and now we have C16 and C12, which I believe C16, C12, according to the BOM bill of materials, would be C16, C12 should be the same, 10 microfarad capacitors, and I'm lucky that I left two over here. So I'm going to come across over here and apply solder to one pad on C12 and one pad on C16. Then what I'm going to do is take the part with the tweezers, push it in to one side, let go of the iron, do the same thing for C12. And then I'm going to come back on the other side and solder the other side. What I find is once you solder both sides, go ahead and touch up the part again. Sometimes what you'll find is the joint actually really didn't take, and it, so the part will actually fall off, which is not a good sign. Okay, so we finished U5, U4, C12, C16. Again, remember, U4 and U5 look the same, but there is a 3.3 volt part and a 1.8 volt part. The next part would be U6. Looks like U6 is going to be the 1.0 volt regulator, the Texas Instruments regulator, which oh, here it is. This part's pretty small. This one's easier to bridge. This one's on the front. U6 is going to be right here. And there's going to be one side with 2 pins and one side with 3 pins. Make sure to align the part correctly. And what I like to do with these multi-pin parts is tack it in one corner. Then I'm going to bring the part around, tack it into place. Okay, now it's in place. I'm going to go back and essentially fill in the solder on the rest of the pads. Ooh, and I just made a bridge. So let's try first just applying flux. And it didn't suck it away, so we're going to actually need the braid. I'm going to come back with the braid. Okay, and we got rid of that bridge. Remember, don't push into the part. Let the braid and soldering iron heat up and suck away the excess solder. Okay, so U6 is done. U6 is done. Oh, we also, just so you know, we have gloves available too if you need them. R18 and R19. Okay, so R18, R19. So here's R19. R19 is 120 ohm. It is extremely important that you do not mix up R19, R20, and R18. The regulator is the voltage output of the regulator. This U6 part is set by the R20 and R19. So if you mix them up, you'll get a 1.5 volt out instead of a 1.0 volt, and your FPGA is a 1.0 volt part. So yeah, that's not that good. 19. Again, with the resistors, there's going to be, it doesn't actually matter the orientation. Most of these capacitors also don't matter the orientation. There's going to be a white side and a side with a printed number on it. Try to keep the side with the printed number on it up just so we can read what number it is. Again, solder in one side, tack in one side, and come back on the other side to apply solder. And R20 is next. R20 is a 180K resistor. I'm just dumping all these on the floor as I go so I don't get mixed up with the old parts. So another side. Grab the resistor with the tweezers. Place the part in. Come back on the other side and solder. And these are, the smallest parts on this board are going to be 0603, which is actually pretty chunky. If you open up your phone or something, you're going to find like 0102s or something, which are absolutely tiny. So R20 is done. The next one is going to be R18. What is R18? R18 is a 10K resistor. Sounds like it's a pull-up resistor if it's 10K. We can also, I don't know about this one, but for some of the resistors right now, we're going to actually sub in the 4.7 pull-ups because we ran out of 10Ks. So R18 is over here. Okay, so R18, let's see. The next one is going to be C24 and C25. C24 is going to be C24. Well, actually, it's C26 and C25. C25 is a 4.7 microfarad. So let's find that resistor. Oh, sorry, that capacitor. C25. Here's C25. Sometimes these are hard to open initially. So, yeah. Okay. So that's C25. C25 is over here. Come in on one side, apply the solder, take the part, the tweezers, push it in. Then come back on the other side. So C25 is in place. I don't like how it turned out, so I'm going to apply a little flux. C25, C26 is probably, let's see, C26 is going to be 10 microfarad. So 10 microfarad is going to be, let's see. Here. So C26 is over here. Oh, great. That's going to happen quite a bit for you too, probably. I did order enough parts so that we can misplace some of them. Usually the resistors and capacitors, if you lose it, don't worry about it. We're going to come back on C26 on the other side. Okay, C26 is done. Now we have something called L3. So L3 is going to be a bigger looking inductor. Bigger looking inductor. Okay. And the orientation of this doesn't matter either. Actually, the orientation matters, but the polarity does not. So let's see here. So over here we have L3. So I'm just going to pop in some solder. And you see, oops. Oh, it's not, it doesn't autofocus. All right, so there's going to be two pads that are going to line it up with the pad on the board. So L3, apply some solder. And then we're going to come in on the other side, just apply more solder. So L3 is done, so let's see here. F1 is going to be the fuse, so F1, let's go ahead, and the fuse is going to be on the back, so I'll flip the board over. Okay, so the fuse is on the back. Now I'm going to go ahead and apply solder to one side. And this is kind of awkward because I'm trying to keep the board in the same position. But okay, got one side of the fuse in. Okay. Oh, too off-centered. You want to center the part. If it's crooked, it's fine. It's slightly off, it's fine. It doesn't have to be perfect. But what you want to do is make sure that you leave room on the other side, enough room for the pad so that you can come back and apply solder and that both sides are actually connected. All right, so F1's done. U2, what is U2? According to our BOM, U2 says it is the UMFT chip, which is this right here. It's going to come in this bag, and it's going to look like this. Okay, so I'm going to flip it around. I'm just going to align it here, and then just solder. Oh, it's out of frame. Hold on. There we go. So I'm just going to solder one pin so that it doesn't move. And then solder the rest of the pins. So this will be the UART to USB converter. It's not the one that programs, but it is going to be the one that communicates via UART for one of our subsequent labs when you're going to build a state machine to transmit and receive UART. So that side's good. Let's see. All right, that's soldered in. So F1, fuse 1 is in, U2's in. Then the next set of resistors are going to be primarily over here. So R5, oops. Guess I'll solder them this way. So R9, R10, R11. Those are going to be R9, R10, and R11, and R8 are all going to be 0 ohm resistors. So it's labeled line 6. One, two, three, four. All right. They're 0 ohm resistors, R9, R11, R10, R8. They're all 0 ohms. The reason we want 0 ohm resistors is maybe we want to modify this design. We could have just put a short in, but what if we needed to modify the programming setup, right? These resistors are connected to the programming pin for the FPGAs, the FPGA programming pins. They're called M2, M1, and M0 if you look at the data sheet. I think it's user guide 470, not sure though. When we have a row like this, I just like to go down and apply solder to the entire row, and then go down with, let's see, R10, R8, so R10, and then R8, and R11, and R9. And we need one more resistor from that pile, or that reel of 0 ohm. Oops. This is R11. And then R9 is going to be what? R9 is going to be, oh, R9 is 0 ohm as well. Oh, I'm reading the the bomb up the silk upside down. That's an R6. Ooh, that would not be good. R6 is a 4.7 k ohm. .7 k ohm. It's over here. Shouldn't have put that on first, but whatever. All right, so I'm going to come back on the other side and just fill in the solder going down that entire row. Okay, so we have filled in R5, R11 is filled in, R10 is filled in, R9 is filled in, R6, R7, R5, and R7. There's an R5 over here, which I didn't fill in. An R5, according to the bomb, is going to be 4.7 k as well. The order is somewhat important here. I've told you a certain order because it makes it a little bit easier to assemble. Like, if you were to assemble this reset button first, you wouldn't be able to get to R5 as easily. So R7, I wonder where R7 could be. R7 is a 330 ohm resistor. Oh, okay, that's where they are. R7's over here. So R7 is going to be a 330 ohm. R4 is also going to be a 330 ohm resistor. And I'll just fill in the entire row, because we will have R7 and R4 as 330 ohm resistors. They are usually on a reel because we use quite a few of them. Here's a reel. By the way, when you take components out from the front of the room, if you're in my class, please don't clip it off. Just peel it off so that we don't have to kind of pry it every time. Okay, so 330 ohm. Again, resistor orientation doesn't matter. Come back on the other side. Tip's kind of getting dirty. I'm going to clean it off. Okay. Okay. The next thing we're going to have to watch for is going to be the LEDs, which is D20 and D30. So we'll have two of these here. And I can't exactly show you because I can't exactly autofocus on the small part. But on the LED itself, the orientation is going to matter. There's going to be a side with a green stripe. That green stripe has to face towards the silk on the PCB with the white. There's going to be one side with a missing white edge. The green line on the LED is going to have to face towards the side with the white edge. Okay. Let's go ahead and do that. And remember, the LEDs are actually plastic, so they're a little bit less resilient than the capacitors and the resistors. So that green stripe facing towards the white on the silk screen. Just realized I forgot to tell you what the silk screen is. The silk screen is essentially it's the white text printed on the board with the reference designators. And so the reference designators are going to be the D20 R4 telling you where what the part is on the bill of materials and where it belongs on the board, if you haven't caught that already from watching this long. Okay, so we'll apply solder on the other side. Okay, now what we need to do, these are male breakaway headers. We're going to need to put the programmer header in, and I'm just going to break away what I need. We're going to come back in here, and we can't use this vise. So what I'm going to do is going to put the header on. I'm just going to solder one header on, or one pin rather. Come back and see, just make sure that it's aligned correctly, straight. Doesn't really matter, it's more aesthetic, but then I'm going to go back and fill in all the holes. Okay, so when you're filling these through-hole components in, you want the shape to look like a Hershey's Kiss. If it balls up, you put too much solder on. What you need to do is make sure that you're applying heat to both the pin and the pad. Touch both the pin and the pad, feeding the solder in, right? So as you solder, touch the tip of the iron to both the pad and the pin, feeding the solder in until you get kind of a Hershey's Kiss joint shape, right? Right. So at this point, what should be the case is you should be able to test the board now, which you should see your instructor to test the board. Okay. After you're done testing the board, we're going to continue with the instructions. And oh, it says R4. Did I put R4 in? Yes, I put R4 in. So we're going to continue with the instructions, and it says, please continue populating the following parts. All remaining LEDs except D13. So let's see. Let's come back here. I'll do this because this is going to be easier in this orientation. I think we should have enough LEDs. I hope. Well, whatever. Okay. So, with a row of components like this, I'm just going to go down, applying solder to each pad. Remember, the LEDs are polarized. There's only one polarity. There's one orientation. I'm just going to take all these LEDs out. Oh, okay. And then remember, there's a green stripe on the package. It's kind of hard to see. The green stripe should face towards this, towards the switches on the board. Green stripe towards the switches. And I'm just going to go down, tacking them in. You should try to keep it neat, but it's your board, not mine. D7. D6. D5. D4. I know you're going to complain about how small these parts are. They're really not that small. And I am missing one pin, so let's see. Or so one LED. Let's try to match the color up. I think I'm using green here. So one more D0. Okay. All right. I'm going to flip the board around, and I'm just going to fill in the other side with solder. The LEDs are more sensitive to heat. They are plastic, they will melt, so watch out. So the LEDs are done. Remember, again, the orientation of the LED, the green stripe goes towards the switches. The green stripe goes towards the silk, the white silk. The side with the missing silk line for the LED does not get the green stripe, okay? In fact, after you place one LED, come see me just to make sure that the polarity is right. Otherwise, you're going to have to rework it. So let's say that you did mess up, though. Let's say you messed up. How would you remove a part? For a 2-pin part, I would just heat this part up. Oh, R5. I'm going to heat both sides up and then get rid of the part. Now what happens is when you go to replace the part, what you're going to end up is there's going to be solder on the pad. The part's not going to sit flush. You're going to have to take this wire braid or solder wick, apply it to the pads just to, you know, get the surface flush again so the part will actually sit flush. Okay, I'm going to come back on one side, apply that, grab the new replacement part. That looks right. And just apply the part as normal. But, excuse me, remember you'll need to use the braid to flatten the pad again, or to remove the solder from the pad, just so that the part sits flush. All right, so LEDs are in. What should we start doing? Well, it says here I can start soldering all the remaining capacitors and resistors. So let's go with C13. C14, C11. C13 is going to be, C13 and C14 are going to be 0.1 microfarad capacitors. Oh, there's an entire reel of them. Here. Again, when you're removing parts from the reel, just peel back. Please don't cut the part flush, or else it's going to be harder for the next person to remove it from the package. So again, I'm just going to start with, let's see, C13. C14. Come back on the other side. Let's grab the rest of this 0.1 microfarad capacitors as well. It says here C 6, 7, and 8. 6, 7, 8 get the resistor, the 0.1 microfarad capacitor. C5 is also a 0.1 micro. I'm just going to put one drop of solder on one pad just so we know. C18 is also C4. Just going to get some solder as well, just so I remember to solder that. Let's grab some more capacitors. And just start placing them. Oh, it says C15 is also 0.1 microfarad. And these ceramic capacitors aren't polarized, so orientation doesn't matter. Try to get it kind of straight on the pad. Remember, when you put the part on it, leave enough room on both sides so that you can actually solder it. And if you don't like the way the joint looks, again, remember you can just come back with some flux and make the joint look a little better if you want. When you're soldering, make sure that you touch both the pad and the part. Oh. I don't like how some of the joints turned out, so I'm just going to put a little flux down, fix the joints. Oh, see, that happens sometimes when you touch up both sides. The part will fall off again. Just put it back. That means that you didn't solder it, the part correctly to both sides of the pad. Okay. So I think I have a lot of that. Let's try to put the 10 microfarad capacitors on next. I think that's it for the 0.1 microfarad. Not sure though. Oh, here they are. So for the 10 microfarad capacitors, and again, how do we know all of this? We're going back to the bill of materials and just coming back to the board and finding the part location and putting it in. So C18, let's see here, 10 microfarads, I see a C1, a C20, so C20 definitely gets one. And a C1 over here. C3, nope, C3 does not get one. What about C17? That's a 10 micro, yes. Okay. I know I'm going a little slow, so feel free to use the YouTube feature or whatever platform this is on to kind of speed up the video at like 1.25 or something. And I'll save these 10 micros for later. All right, so we had to take a little break. What I did was I kind of just arranged all the components here that I need. So I'm not going to tell you what components they are, but reference the bill of materials, find the component and place it in the correct position. But I'm just going to start soldering. R16 is going to be 330 ohm. R15 is also going to be 330 ohm. We're going to do, let's see, what else? C22 should be 1 micro. C24 and C21 should be 1 micro as well. C45 should be the 15 picofarad capacitor. Now R14, R13, and R12 are all going to be 330 ohm as well. Remember, release the iron before you release the tweezers. All right. There's going to be two parts called RN4 and RN3. They're resistor networks. They're 330 ohm. I'm going to clean the tip before I place it. Come back here and just place a 330 ohm. There's multiple tabs on this, so it's going to be might be a little tricky. Might need the solder wick. Yep, I definitely need some flux or some solder wick on this part. It's a little tricky. Sometimes you can just get away with just applying flux, and it'll kind of even it out enough so that you don't have to use anything else. To flip the board around. Oops, uh-oh, something went flying. Oh, the other resistor network wasn't soldered yet. Come back, oh. Let's apply the flux first before we do the wick. See whether we can kind of get it to flow where it wants. Oh, nope, not gonna work. All right, let's apply the wick. And these are connected to your LEDs, so if you don't get it right, then your LEDs might be shorted out. Okay, I think that's good. The other resistor network, let's place that as well on RN3. Black side up, so we can identify the component when we need to. You know, when I put these resistor networks in, I was trying to reduce the bill of materials so that you wouldn't have to solder as many components. Thinking about this kind of makes it harder to solder. Okay. One thing that I didn't mention before was if you apply too much heat to the part, you can damage it. And you can damage the board too. Placing too much heat, like placing a lot of heat and just leaving it there for a while, the board is glued together. The glue will delaminate, and you might have to do a board repair or scrap the board. So don't leave the iron like sitting on the part. It's okay for a couple seconds at least, but anything more than that is going to be probably an issue. So let's see here. There's a couple more resistors here. R3, R1, R2. That says on here that those should be R3 and R2, but R1 should be well, let's just go with R1, R2 and R3. R2 and R3 are going to be 4.7 microfarad, 4.7 ohm, 4.7 K ohm. Uh-oh. Well. Okay. I think I just placed the wrong resistor. R1 should be 2.4K, so let's remove that. Place it to R3. Honestly, if your joints don't look perfect, it's fine. You can come back, touch it later with flux. You're never going to probably get it to how the machines do it. So you could definitely tell the difference between a machine-built board and a human or handmade board. R1 would be a 2.4K resistor, so 2.4K it is. Okay. And I think what I'm going to do is flip the board this way to get All right, so the resistors down here are all going to be around the switches R31 and R23. I'm going to do 4. Oh wait, it's either 4.7K or 10K. I'm going to go with 10K. I think we have enough 10Ks now. Okay, 10K ohm. Should have enough of these. R29 is 10K. R26, R28, R27, R32, R25, R24. Oh. R23. Oh. This would be easier if I wasn't videotaping this. I don't know why I said videotape, because this is a DSLR, but whatever. I'm just going to flip the board and just solder the other side now. So the resistors are in, capacitors are in. Let's see what's left. R17 is missing. What is an R17? An R17 is a 10K ohm resistor, so R17 has 10K. Okay, what else is missing? C3, let's go for C3. C3 is a 1 microfarad capacitor. One of these parts just lifted off the board. Let me just fix this. There we go. C3. Okay, so I think most of the parts on the back for surface mount are done. Front still has plenty of parts to do, so yeah. Okay. Okay, what part should I do next? C19 is going to be, C19 and C11 are both 1 microfarad, so let's do those two. Okay, so C3, C19, C11 is covered. What is C10? C10 should be a 10 microfarad capacitor we have sitting here. Let's just pop that on. Yeah, sometimes you don't have enough room on the other side, then you have to move the part again. There we go, C10 is done. L1, R22, and L2 are not populated. R21 should be populated with a 0 ohm, so let's find a 0 ohm resistor for R21. And just go ahead and pop some solder on. I seem to have misplaced the resistor already. Okay. Have to grab another one. I wonder if I can jumper it. Sometimes if you just put a bunch of solder, you can just jumper the connection. Oh, yep, there you go. I just bridged it. 0 ohm resistance achieved. D13, so D13 is going to be, yeah, let's do that one next. There's going to be an oscillator called X1, and there's going to be a D13 LED. Orientation is extremely important, so let's get the oscillator. And let's get an LED. oscillator is going to be a little tricky, so just flip it around a little. The oscillator is going to have a circle on it. I can't show you on the video, but if you look at it, it's going to be rectangular. There's going to be a circle. The circle on the part should match up with the circle on the board, or the pin 1 designation. I'm going to apply some solder here on the pad, bring the part over, kind of align it with the silk. Oops. There we go. Make sure that the reference, the marker for pin 0 or pin 1 is matching circle with circle. Okay, go around. Just apply some solder. That should be good for the oscillator. The next thing is the LED. When I designed the board, I made a mistake. I put the reference designator on this version, on version 1.2, facing the wrong way. The notch on the LED should face towards the FPGA. So the notch should face towards the FPGA. There's a little notch here. Towards the FPGA and switches, the notch should face towards the switches, okay? So the notch is here, switches are here. Let me just, it's actually easier for me to not use the device, but the only reason I'm going to keep using it is because it'll keep the board in frame. Watch, the board goes out of frame as I say that, right? Anyway. All right, so grab that part. Remembering that this particular part, I kind of put the reference designator on wrong. So here, do this. Apply heat and solder. Align the part, let go. Remember to keep enough room on both sides so that you can come back and fill solder in on both sides. Okay, you got your D13 on, you got your oscillator on. R22, L1, and L2 are no connection. The next thing that you want to probably do, according to the instructions, got our D13 on. We can solder our buttons on now. There's a reset button and 4 buttons over here labeled SW. So here's a reset button. They only go in one way, as in there's tabs coming out on these two sides. So you should just be able to press them in like this. However, it's going to fall out, so I made the holes a little too big, so I'm just going to bend the pins over just so the button doesn't fall out. There we go. And I'm going to continue placing the buttons in this corner over here. If you have to push them in real hard, you're doing it wrong. At least on this board. I made a board with the holes too tight, then you had to press really hard to push the buttons in. So again, I'm going to come back on the back side and just fold the leads over, just so the button doesn't fall out as I try to solder them. Okay, alignment looks fine. I'm going to flip the board over and make sure that it kind of looks okay. I think that's the best it's going to get. All right. So now I'm just going to go back and fill in the solder holes, the through holes with solder. Again, touch both the pin and the pad. Let the solder suck into the hole for through hole components. Okay. again, you're applying heat to both the pad and the hole, and you want the solder to suck into the hole. If your solder is not sucking into the hole, then it's not making a good connection. If it turns into a ball, you're applying too much solder. Okay. I think those buttons look good now. The next thing to do, oh, I forgot U1. That's probably not necessary this year, but let's put it on anyway. So it's a chip. So it's this chip, U1. The dot on the chip goes towards the dot on the silk screen on the board. On this part, I'm going to apply some solder on one pad, align it in place, making sure you leave room on both sides for to solder. Then I'm going to go back and fill in the solder. All right, there, done. Okay, There's C23, but I'm going to leave it blank for now. I think we should be done, except for a couple more connectors. Uh-oh. Ooh. So I'm going to move this out of the way because won't be able to solder otherwise. So you're going to have some connectors. Put on the connectors over here, right? We go here, J7, J6, J5, J3, and J4. But they're going to fall out if I put them all in at once. What I'm going to do is just put this one in. I'm going to tack it in 2 places, just so it doesn't move. Okay. So now we have that connector in place and ready. Okay, so there's another header I'm going to put in. Again, tack it into place. 2 positions just to keep it in place. Now there's this connector here, J6, X mod 1. Again, I'm being hit with a bunch of solder fumes. If you're actually doing this in lab, please use the vent. The only reason I'm not using it right now is because the audio quality would be horrible. Okay. Okay. So we got all these connectors in place now. Now what we have to do is come back and essentially fill in all of the holes. Again, through hole components, heat both the pad and the pin. A joint that looks like a Hershey's Kiss shape is probably good. If it looks like a bubble or a ball, you probably put too much solder in. So let's go ahead and keep feeding in. As you feed the solder, remember to keep your fingers far away from the soldering iron. You don't want to get burned. I've seen people like literally feed it up to their fingers. Oh, one other tip is the pins on these through-hole devices, the connectors on this, they're kind of a tin color, not tin, but a goldish color. If you see the gold color, you probably need to add more heat as well as solder. While I'm just filling these in, ideally what happens with that BGA package with the balls underneath, this one's a particularly, it's 196 pin, it's not that big, it's not that fine pitch. If you watch the other video that I linked to on YouTube from Strange Parts, you'll see that he's at a factory with a bunch of test equipment. One of the pieces of test equipment has the BGA X-ray to see underneath the board to see were the balls properly adhered to the board, did they melt, and did they actually make a connection. Generally speaking, there's not a need for that, but for high reliability, I would probably do that. If I was depending on this, I'd probably try to have some other way of verifying that the BGA package actually stuck properly. But in this case, this is a pretty low reliability product for a class, so we're not particularly concerned. You probably will just throw this away after the class is over. You shouldn't, but you will. Well, some of you. Yeah, soldering isn't the main point of this class, but it is useful to know how to, build a board for your, let's say you're at a design firm, a very small company, kind of need to know everything from the firmware to how to build these boards, how to program the boards. You can't depend on just a technician. Like at a bigger firm, you'd actually have a bunch of different groups of people who you could rely on, but let's say you're at a startup or a small firm, you're just going to have to learn how to do a lot of this stuff yourself. All right, so headers are soldered. At this point, what we need to do, I'm going to go dunk this board in the ultrasonic cleaner just to clean off the residue, and then the final thing I'm going to do is just put these switches in. The reason I'm not putting these switches in right away is because if you put the switches in the ultrasonic cleaner, there's kind of some lubricant in the switch that kind of completely dries out. So I'll be right back after the ultrasonic cleaner. All right, we cleaned the board in the ultrasonic. We blew it out with the hot air, not the hot air, the compressor, the air compressor. Normally, what you'd probably want to do, especially with the BGA, is kind of bake it in an oven. But we don't have an oven, so we're just we just use not the hot air. I keep saying hot air. Just the air compressor to blow out some of the residual water. So we have the switches now. All we have to do is place the switches. And again, unfortunately we have to do the switches separate, because if we don't do the switches separate, what happens is there's some sort of lubricant in the switch, and if you dunk the switch in the ultrasonic cleaner, it dries out the lubricant, and your switch can barely move. So not a good thing. Okay. Oh, all right, let's go ahead and start soldering again. Again, we just want to fill in the holes with solder. What I'm noticing with the top and bottom pads is you're going to have to apply heat a little bit longer just to get the solder to flow properly. If the solder doesn't stick to the pin, or it looks like it's not sticking, you just need to apply heat longer. Okay, so that's it. Except now we have some residue on the board, so I'll be right back. I've got to get a toothbrush. So I have a toothbrush and some isopropyl alcohol. Realistically speaking, you're supposed to use an ESD-safe brush and work in an ESD-safe environment. We're using a toothbrush and we have carpeting in this room, so we're not that ESD safe. And realistically speaking, if this was production, this board would probably be scrapped. We haven't followed any proper ESD procedures. But it's probably going to still work for the duration of this class. A lot of the ESD damage seems to be like long-term anyway, over the course of a long time. And we only need this board for like until the end of this term. Hopefully that cleans it up enough. All right, I think the board's done. So at this point, what we need to do is actually, we've tested it before. We're going to test it one final time, test that everything's working. The board looks clean. All we need to do is do the final test, and I think we're going to be good to go. When you use your board, you're going to have you're going to be provided a USB micro connector for this. This is how the board is powered. Over here, USB connectors, the micro is notoriously weak. That's why I kind of bought the interposer with the USB to UART transmitter as well. So, you could just swap it out if it breaks. Plus, we don't have to put any more components on, $5. Now, before I wrap it up, we do want to try to stay ESD compliant now. This is an anti-static bag. What you want to do is, when the board is not in use, just keep the board in the anti-static bag, right? That'll keep it safe. When you do want to use the board, take it out of the anti-static bag. Don't sit it on top of the anti-static bag after you turn it on. And I think that's it. We're done with the OwlFPGA version 1.0.